Please welcome Philipp Meyer, RWTH Aachen University.
Hello, my name is Philipp Meyer. I'm Head of Entrepreneurship at RWTH Aachen Innovation. At RWTH Aachen Innovation, we support the 45,000 students and almost 7,000 researchers from Aachen University to turn their ideas and innovations into groundbreaking startups. And spoiler, we seem to be doing quite a good job at that. One of those startups today is Roofline. We nominated Roofline because they are breaking walls in the deployment of AI to the edge. Roofline deserves to be the science breakthrough of the year because with their novel compiler software, they allow us to run any AI model directly on device, which will allow groundbreaking new use cases and increase European sovereignty in AI technologies. Thank you very much.
Breaking the wall of edge AI limitations. Thomas Zimmermann, Roofline.
At Roofline, we enable developers to run any AI model directly on device. Today, most AI applications are run in the cloud on large data servers, as you probably know from ChatGPT. In the future, these overpowered cloud services will move more and more towards targeted edge AI applications run locally on different devices. And this will unlock the next generation of AI applications, for example, in energy-secure robotics and drone systems and data-private automotive and also medtech applications. But while cloud AI is moving at light speed, edge AI is actually failing to really take off. In cloud, NVIDIA has built the gold standard software ecosystem to easily run any model on their chips. So you can literally download an LLM from Hugging Face and build a chatbot with it in a matter of hours. But at the edge, this actually takes several months. Do you remember beginning of the year when DeepSeek was released and everyone was freaking out? It literally took 3 months until you could run it locally on a device like this. And this is because the models which are there and the chips which are obviously also here literally speak different languages. Because the deployment layer that connects the models to the hardware is missing. And Roofline provides this translation layer. At its core is our breakthrough AI compiler technology. Building on research at RWTH Aachen and combining that with world-leading expertise from AMD and Intel, we designed a software layer that finally connects AI models and hardware at the edge. Our secret sauce is modularity. Our compiler leverages so-called multi-level intermediate representations, which can accommodate all types of different models from different frameworks and then run them through different levels of mathematical abstractions. So while other solutions need to rewrite really their whole stack if a new model architecture like transformers is being released, with our stack, a new model is more like learning a new vocabulary, and targeting a new hardware is more like understanding a new dialect of your language. So with our solution, DeepSeek literally was supported on the day it was released. This is what excites our customers, and I will also show you why. With our solution, each and every one of you could build their own autonomous robot, for example, for a warehouse application, without knowing anything about programming. Here, we run a multimodal LLM directly on a device like a Raspberry Pi. Multimodal, like Gemma 3 here, means that it combines both vision and language. So the model takes this image, this camera view as an input together with your prompt, and then the robot reasons that it needs to slow down and adjust its path. This is run fully on device, no custom algorithms, just the model downloaded straight from Hugging Face. And this excites our customers, the companies offering these hardware chips, because for them, they can unlock new applications, they can enter new markets, and most importantly, they can accelerate innovation of developers on their specific hardware. Based on this, we reached major milestones within just 18 months after incorporation. In product, we now have day zero support for these cutting-edge models on CPU and GPU, just like DeepSeek and Gemma 3 that I just showed. Today, we're working with 2 S&P 500 customers to enhance software support for their specific AI chips, with a clear path towards licensing our full-fledged software development kit. We raised 2 rounds of funding, and earlier this year, we were awarded the most prestigious European spin-off award for deep tech startups, the EIC Accelerator, as one of the youngest companies ever, just a good year after our incorporation. This speaks for our insane speed, and this is mainly enabled by our team. Most importantly, we managed to hire an entire team of senior engineers from AI big tech companies like AMD and Intel. With this team, we are now breaking the walls of edge AI limitations out of Europe.
Out of Europe sounds great.
Right?
This is cool. Very good. Questions? Iris? Yes, I knew it.
Thank you. I was curious, what still needs to be proven before you can move ahead with the licensing business model?
Yeah, so it's 2 things. So first is CPU and GPU are like quite generic hardware, but then we also need to onboard like the specific AI accelerator hardware that these vendors typically have on their chips. And that's what we're doing in the pilot project together with them. And the second one is really around stabilization. So we can like generally support a lot of models pretty quickly, and that's what we show them. Like they bring like their weirdest model and it runs super fast, like quickly in terms of onboarding. But still, there's a lot of stabilization to have like really a pool of many models that always run.
Okay, I'll take Stefan first. I don't forget you. Please.
What's the impact on latency if in your compiler model? Do you have any experience with that?
Yeah, so there are basically 2 key metrics that we measure, and the most important one is always latency. But for us, it actually comes second because the main value add is really this time to market and enabling all models. But we always benchmark against mainly open source solutions, and we are mostly on par. But it then also differs. In general, we are better for larger models, like larger LLMs, rather than highly optimized like vision models, for example.
Great. Inga and then Syriac for sure.
Perfect. Thank you very much. I would like to understand the competition from the US.
Yeah. So the interesting thing is, so I think 2 points to this. So first one is that talent is very scarce in this space. So there are just not many compiler engineers, specifically not for AI. And then in the US specifically, they are right now all drawn to server because just server is right now still 100x market compared to this. And then all of the big tech companies usually get the best talent there. And that's why we're currently the only company really working on this technology for this market.
I love it when they say we are the only company that does that. Syriac, please.
Question, is the speed to conversion the key factor, or is the size of the compression or of the compilation most important when you run it on a mobile phone? In other words, why do if it's the former, why do the 3 months matter so much?
Because it just speeds up innovation in the end. And you can really, so I think it's 2 things, right? One is you have a certain hardware and you need to have software, like a new hardware, and you need to enable it to bring it to market. And we could speed it up by probably half a year to a year, which is just massive in terms of bringing it to market. And then second is enabling customers to build applications on this hardware. And that's key because it's just innovation speed. And people, in the end, it's like people want to try out and run models on hardware. It just doesn't work, so they go to competitors.
Mm-hmm. Andres, please.
You mentioned several times how important speed is. On the other hand, you have to balance it somehow with defensibility of your intellectual property. You're not using patents, as far as I understood you. So how is this going to work, especially in an open source environment?
Yeah, agree. So we don't have any patents yet, and we also see it not too critical for us in this space. That's A, software, which is in Europe difficult anyways, and B, moving so fast. And then the open source aspect goes to it, but actually open source is one of our key defendability assets that we build up. So we're building on a lot of open source infrastructure, and we're building a lot of influence there, especially for our market. And that's actually adds tons of defensibility together with the partnerships and relationships we build with these hardware vendors.
Last question, then 20 seconds, short
Yes.
answer.
What would be the biggest enabler for you to scale?
The biggest enabler?
12 seconds.
Yeah. So convincing these chip vendors of partnerships and getting like
So
the
it's
biggest players.
the chip vendors.
Exactly.
Yeah.
And
In
then,
Europe, can you get that?
we have some, so we're definitely working on it.
That's an excellent answer. You have already them. This is great. Thank you so much for this. Out of Europe.